Okay. First of all, thank you for joining this live session. My name is Abhishek Datta, and I'll be taking this problem-solving sessions of the course Soil Mechanics Geotechnical Engineering 1 that will be held on Mondays, every Monday from 6 p.m. to 8 p.m. And I'll be proceeding these problem solving sessions as per the syllabus given in the NPTEL website. So it is basically a problem solving sessions on soil mechanics where each and every concepts starting from the soil origin, index properties, soil properties, engineering properties, permeability, compaction, compressibility, consolidation, then the strength, engineering property, shear strength, earth pressure, stability of slopes, everything will be discussed with the help of some question answers. These sessions are going to be interactive sessions. So first of all, I'll be starting the session. The session is going to be recorded, and those who have not joined can also find the recorded version of the sessions on the YouTube channel, which I'll be uploading the very day itself. So I'll start the session and then I will first of all dictate some questions, a set of 15 to 20 questions, which can combine, numericals, multiple choice questions, multiple select questions, true and false questions. So I'll first of all dictate, and you all have to either write down or take a screenshot of those questions. Take a screenshot of those questions, and then after I dictate all the questions, I'm going to give you some time, uh, minimum 10 minutes, maximum 20 minutes, so approximately 15 minutes of time you will get, after which I'll again start with the solutions of those particular questions. So I'll be asking you all the answers of the question. Those who will be able to answer will have to explain how they have solved it, and if you can't answer the question, I'll definitely give you the answers along with the solutions and the explanations behind the same. So this is going to be an interactive sessions. So I hope when I ask questions, you have you can interact, you can answer either through your mic, and if your mic is not working, you can also always drop some messages in the chat. Anything will help. Okay. So this is the first session, and the topic of the first session is origin of soil and its classification. Origin of soil and its classification. So I've already started the recording of this video. I'll just switch the tab to go to the PPT. So the PPT is visible, right? I'll start with the uh, dictation of the questions. Okay. So you all can write down the questions or take a screenshot, whatever is feasible, and then I'll give you time to solve those questions. Okay. So the first question, I'll just check once. Yes. The first question is, what is the type of soil formed after deposition in lake water? No need to tell the answer or message in the chat the answer right now. Those who know the answer, they can write it down. We'll discuss it after I dictate all the questions. The question is, what is the type of soil formed after deposition in lake water? So the topic is origin of soil. So how the soil is formed? We have some questions on this particular topic. So the deposition of soil is one of the formation stage of the cycle. How the soil is first formed, then transported, and then deposited. So in that very case, when the soil is deposited in the lake water, then what is that type of soil called? The options are alluvial soil, number one; number two, lacustrine soil; number three, colluvial soil; and number 4, marine soil. So those those who have joined a bit late, okay, people are still joining. Is this available in YouTube? No, it is not yet available in YouTube. I will be uploading the video in YouTube after I finish today's class. So this is not yet available in YouTube. Okay, and those who have joined late, the session start exactly at 6. Today I have just given a brief introduction about the course and about myself, and this is the first question. So there is no worry, you can write down the question. I'll again, dictate it. The first question is, what is the type of soil formed after deposition in lake water? Okay, so I've already mentioned to the people who have joined earlier that write down the questions first, then I'll give you some time, 10-15 minutes. Within that time, you can solve the questions. After 15 minutes, I'll again join, and then we can discuss the solutions to the answers to the questions. Okay, those who have done, those who can solve, will explain the answers along with the solutions, along with the explanations of the solutions. Okay, so okay, I again repeat. The first question is, what is the type of soil formed after deposition in lake water? The options are alluvial soil, lacustrine soil, colluvial soil, marine soil. These are the 4 types of soil. These are the options, and which of this is deposited in the lake water? Okay, so this is the first question. I'll move on to the next question. A lacustrine deposit with alternate thin layers of silt and clay is called. A lacustrine deposit with alternate thin layers of silt and clay is called. Your options are loam, muram, bentonite, or warped clay. Again, those who are joining late, write down the questions. I'll give you time to solve them, and then we'll discuss the answers. The second question is, a lacustrine deposit with alternate thin layers of silt and clay is called. The options are loam, muram, bentonite, or warped clay. Okay, next question. Which of the following are formed by transportation by gravitational forces? So again, we are in the origin of soil part, and the origin of soil consists of formation, deposition, transportation of soil particles from one place to another. So there are many agents of transportation: air, waters, gravity, wind. So among those, if gravity is a transportational force, the soil transported by gravitational forces, then which among these soil will be formed? The options are loess, till, laterite, or talus? This is the third question I'm dictating. Those who have joined late, which of the following are formed by transportation by gravitational forces? Transportation by gravitational forces, the options are Loess, Till, laterite, and talus. I'll just repeat these instructions for the others again. Those who have joined late, write down the questions. You'll get time to solve them. After that, we'll discuss the answer together. Okay. Which of the following? Who is this? Sir, I'm in office. Can you upload the YouTube link in announcement section? No, I cannot upload the YouTube link in announcement section. I have to upload the YouTube link in a Google Sheet provided, and that YouTube link will be shared to you by the NPTEL coordinator. Okay, by the NPTEL coordinator. Anyway, you are going to get the link after today's class, but I cannot share you the link in the announcement section. I have to upload the link. I have to share the link in an Excel sheet of the given to me by the NPTEL coordinator and from there I hope that you all will be also shared the same link. Okay, so again I'll repeat, which of the following are formed by transportation by gravitational forces? The options are Loess, Till, laterite, or talus. Okay, I'll go to the next question. This is the fourth question. Yes. Which of the following type of soil remain at their place of formation? Which of the following type of soil remain at their place of formation? Your options are aeolian, marine soil, residual soil, or colluvial soil. This is the fourth question I'm dictating. Which of the following type of soil remain at their place of formation? That means wherever the parent material is degraded, the soil is formed. The soil is formed in that very same location. The soil is formed in that very same location. So, which type of soil remain at their place of formation? Your options are aeolian soil, marine soil, residual soil, or colluvial soil. Okay. Next question. Which of the following processes may lead to disintegration of rocks? Which of the following processes may lead to disintegration of rocks? Your options are chemical, physical, biological, or all of these. I'll repeat the question. Which of the following processes may lead to disintegration of rocks? The options are chemical, physical, biological, or all of these. Chemical, physical, biological, or all of these. Okay, next question. This is a true false statement. Soil transported and or formed by different processes are constantly subjected to further change by physical, chemical, or biological actions. This statement is either true or false, you have to state. I'll repeat the question once. Soil transported and or formed by different processes are constantly subjected to further change by physical, chemical, or biological actions. You have to state whether the statement is true or false. Okay, I'll go to the next question. Yes. Which of the following processes leads to change in the structure of the rock and not its composition? I'll repeat. Which of the following processes leads to change in the structure of the rock and not its composition? The options are carbonation, hydrolysis, reduction, or abrasion. I'll repeat the question once. Which of the following processes leads to change in the structure of the rock and not its composition? Which of the following processes leads to change in the structure of the rock? That means only the structure, that is the physical structure of the rock, is modified, but the composition, that is the mineralogical composition of the rock, is not changed. There is no change in the mineralogical composition of the rock. So the process is either carbonation or hydrolysis or reduction or abrasion. Okay. I'll go to the next question. Cohesionless soils are formed due to. Cohesionless soils are formed due to. Your options are number one, oxidation of rocks. Number two, leaching action of water on rocks. Number three, physical disintegration of rocks. And number four, wind action. So I guess everyone has idea about what cohesionless soils are. Everyone has idea about cohesionless soil. soils which have very negligible amount of cohesive force between its particles. Yes, non-sticky soil. Krishna is saying non-sticky soil. This is, you can say non-sticky soil, but it is not a engineering term to use. Okay, soil doesn't have intermolecular attraction. Yes, and that intermolecular attraction is called cohesion. Good. Shakti Shamanta, yes. Soil does not have intermolecular attraction. Intermolecular attraction is known as cohesion. Yes, Rajavardhan, C is zero. So sands, gravels, these are the kinds of soil where cohesion is absent or it is very negligible. So those soils are formed due to, the options are oxidation of rocks, leaching action of water on rocks, physical disintegration of rocks, or wind action. Which process are majorly responsible? So it is not like if one is responsible, the others might never form. No, but majorly which process is responsible for the formation of those kind of soils where the cohesion is negligible or zero. Okay, oxidation, leaching action, physical disintegration, or wind action. Okay. No need to write the answer or whatever you think the answer is in the chat right now. You write down the questions. I'll give you time to solve them, and then we'll discuss after some time. It's okay. No need to be sorry. Okay, so I'll go to the next question. Okay, so this one I've discussed. Again, a true or false statement. Weathering process related to the activities of microorganisms is termed as geochemical weathering. So there are many, positive factors behind the weathering process of soil. Weathering process of rocks basically, which lead to the formation of soil. So these weathering process, when it is related to the activities of microorganisms, okay, microorganisms, then it is termed as geochemical weathering. You have to state whether this statement is true or false. I'll repeat the question once. Weathering process related to the activities of microorganisms is termed as geochemical weathering. Is this statement true or false? Okay. Go to the next question. Yes. Uncemented deposits of mineral and or organic particles covering large portion of the Earth's crust is called. Uncemented deposits of mineral and or organic particles covering large portion of the Earth's crust is called. The options are rock, loam, soil, or aggregates. Rock, loam, soil, or aggregates. I'll repeat the question once. Uncemented deposits of mineral and or organic particles covering large portion of the Earth's crust is called rock, loam, soil, or aggregates. Okay. All right. I'll go to the next question. The next question is, Alluvial deposits at foot of hills or mountains is known as. Alluvial deposits at foot of hills or mountains is known as. The options are deltaic deposits, loess estuarine deposits, or Piedmont deposits. Which among these are alluvial deposits but deposited at the foot of hills or mountains? Some people are joining now. The class is scheduled to start at 6 p.m. Okay, and write down the question. You will get time to solve them, and then we'll discuss. So I'll repeat this question. This is, I think, this is the 11th question. Alluvial deposits at foot of hills or mountains is known as. So the options are deltaic deposits, loess estuarine deposits, or Piedmont deposits. Okay, I'll go to the next question. Yes. The biggest size of a clay particle is. The biggest size of a clay particle is. So I think you have idea right now about the particle size distribution and about the Indian standard classification of soil based on their grain size, based on the particle size. So as per that classification standard, or in generalized sense, which among these options can be the biggest size of a clay particle? The biggest size of a clay particle. So the options are number 1, 0.003 millimeter. Number 2, 0.002 millimeter. Number 3, 0.0002, that is 0002 millimeter. And number 4, 0.075 millimeter. So in other sense, we can also convert these units into microns. The first option will be I think, yes, 3 microns. Second option will be 2 microns. Third option will be 0.2 microns, and the fourth option will be 75 microns. Okay, whichever unit you are comfortable in, you can write. Try to refer to the grain size distribution of the 4 major types of soils: gravel, sand, silt, and clay. You can definitely find the answer. So I repeat the question. The biggest size of a clay particle is. The options are 0.003 millimeter, 0.002 millimeter, 0.0002 millimeter, and 0.075 millimeter. Okay, I hope you have written down the question. We'll go to the next question. Yes. The next question is, silty clay indicates. Silty clay indicates. The first option is silt percentage is less than that of clay. Second option, silt and clay particles are in equal proportion. Silt and clay particles are in equal proportion. Number three, option number three, silt percentage is more than that of clay. Silt percentage is more than that of clay. And option number four is none of these. So what does the term silty clay indicate about the relative, you know, percentage of silt and clay present in a soil? Okay. I'll repeat the question once. Silty clay indicates silt percentage is less than that of clay. Silt and clay particles are in equal proportion. Silt percentage is more than that of clay, or none of these. I hope you have written down or taken a screenshot, whatever, of this question. I'll go to the next question. Yes. The next question is, BIS soil classification is based on. BIS soil classification is based on. The options are grain size distribution, plasticity properties, both of the above, or none of these. If you don't have any idea, then I'll say BIS is Bureau of Indian Standards. That is, as per the Indian Standard Soil Classification, which are the two important parameters on which that particular classification system is based on. Grain size distribution, plasticity properties, either both or none of these. There can be another two parameters which are important, or any one of these. Okay. I'll repeat the question once. BIS soil classification is based on grain size distribution, plasticity properties, both of the above, or none of these. Okay. I'll go to the next question.